All right, so this lecture is about blockchain. Um, Blockchain, which is a very new technology. It's been out there for, actually not very new, it's been out there for almost 10 years now. It started even before it was there, but the real application of blockchain started back in 2009 when the Bitcoin was introduced. So in this lecture, I'm trying to give you a brief overview of what is Bitcoin, what is blockchain, so you guys have a better idea if this technology becomes um, mainstream or common in the future. Right now, it's even very mainstream. It's growing like crazy, and a lot of companies are investing a lot in blockchain right now. So this is something very new, and I have also done some research on in this area. So I wanted to discuss with you what is blockchain and what is Bitcoin. So first, let's go to the application of blockchain. So Bitcoin is one of the application. So Bitcoin is an electronic currency. If you Google Bitcoin, it has right now a value of $7,840. So you have to pay 7,800 to buy one Bitcoin. If we go back little back, so for example, there are different websites which can give you Bitcoin prices. So Bitcoin is a currency, which is like it's a it's a cryptocurrency. It's an electronic currency, okay, and it was first introduced in 2009 by a guy which no one knows exactly like who's that guy. His name was Satoshi Nakamoto. So that's his name. Satoshi Nakamoto was the guy who actually founded Bitcoin. And initially he was only the owner, then he started trading Bitcoin with other people and it grew. And now it was first started in 2009, 11 years ago. And now it is almost 7,800. Back in 2007, back in 2017, so I'm trying to look for Coin Market Cap website. So this is one of the major um, websites which give us prices for different coins. So if you go to Coin Market Cap, it is giving you Bitcoin, Ethereum, XRP. So all of these are cryptocurrencies which are founded on blockchain. So the technology behind them is a blockchain technology. It's just different kind of a different version of a blockchain, but the major proportion, the major technology behind all these coins, electronic currencies, which are just traded over internet or over a computer, is based on a technology called blockchain. So for example, Bitcoin is the highest market value. It has the highest market cap. So and right now the price is around 7,800. The volume, 24-hour volume is almost $34 billion. And the total circulation, like total coins in the market are 18 million coins right now. So let's go inside Bitcoin and see, read more about it. How the Bitcoin, so it's ranked number one in the crypto market. So it's like you have Forex market where you trade currencies like real world currencies like dollar, euro, yen, pound, different currencies you trade. Similarly, there is a market for cryptocurrencies. Like these currencies are electronic. You can never see them, but they actually exist in computers. So it can be only traded through internet over computers. So this is like from 2013. We can see there is like all. It was really a dead. Like the graph is showing the price over time. So if you can understand, like this was back in 2013, the price was $108. Even before it was just like $4. 2012, I know it was very less. I remember 2012, I got to know about Bitcoin first time, and it was around, I think, $20 at that time. So then it just went pretty much dead most of the time. Not dead, like $400 worth one Bitcoin, because this $412 for one Bitcoin at that time in 2016. But in 2017, the price went crazy. It after like in August, April, May, it really picked up and it touched almost $19,000. So at the peak of Bitcoin time, it was $19,212 for one Bitcoin. So you have to give $19,000 to buy one coin. It was traded at this value. So there was a huge spike and the whole market become crazy. Like there were so much money coming in that the price was getting higher and higher. But then a new year came in. That was in December, sometime in December, and the price started fall. And 2018, 19, it kept falling down. In 2019, it gained a little bit, but still it fall down again. And now it's somewhere here, 7,800, 2020, April 29, 2020, it's 7,825. So from this, what I'm trying to show you, my objective is not to actually explain you how um, Bitcoin trading works, but my objective is to talk to you about the underlying technology. What is and how does Bitcoin works? So let's see, what are these things? So try to understand these figures first. So this is the price. This is the Bitcoin return over investment. So it is return over investment is probably from its inception. It's like 5,000%. If you put $1, it will be $5,000 by now. So it's, I think, yearly or something. So it's a huge return. And when people were here, some people bought it for like $10 a coin, and then it become like 19,000 one coin. So if someone bought it like 100 coins, that would be 1,900,000. So 1.9 million right away. He became a millionaire. So a person who has bought like really cheap, like $100 coins at that time, it would be a millionaire by this time if he has kept the Bitcoin. So Bitcoin was really high. So this is showing the market cap, how much people have put their money in it. So this is the total money invested in this currency is backing this currency. So the total dollar value backed by the Bitcoin is this. Total 24-hour money backed is this one. Circulating supply is 18 million Bitcoins. So we will talk more about it, but just remember this number, 18 million. Total supply is right now is 18 million, but max supply is 21 million BTC. So Bitcoin is termed as BTC. BTC is Bitcoin, is a short form of Bitcoin. So total Bitcoin, which can be traded or which can be used in the market, is fixed. Like in normal currency, like dollar, we can have, we can print as many dollars as we can. So a dollar, we can print as many as we want, but a Bitcoin is something which is fixed. So this currency or this is like, it's like you cannot produce more than that. You can have maximum, you can take out from the vault. If there's a vault, I will go over the vault and everything, how it works, but you cannot take out more than 21 million. Right now, people have mined, so you have to mine the Bitcoin to get this out. So people have mined until 18 million, but they haven't mined the total vault. They haven't mined the whole thing. They are mining slowly. All right, so slowly, it's mining. And once the mining is over, you cannot produce more. With any currency in this world, like currency backed by governments, is like dollar or pound or yen or yuan or any currency, Canadian dollar or anything is backed by a government. This currency is not backed by anyone. It's traded openly, freely, and there's no backing, but the people who are using it are their backers. So the more people use it, the more backers it has. That is the main backing. And then you cannot produce more. Like no one can come up that I will produce 1,000 more Bitcoin. No, you cannot go above this limit. This is the maximum they can take out from the vault. And once the vault dries up, you cannot take out, you can just trade between each other. So you cannot produce anymore. So the point is, so the concept of inflation. So when currencies are produced, there is a huge inflation. So if there's a government or a Fed produces, and if governments say, okay, we have to circulate more money in society. For example, if some governments say, okay, people don't have enough liquidity or they don't have enough money, they can actually print more currency and supply in the market, which will create inflation. So inflation is technically, if you think, is if everyone has a dollar, like everyone in this world has $1, and then a government comes back and everyone wants to buy something which is $2. So if everyone has a dollar, they have to work hard and they have to get someone else dollar to get the $2 stuff. But if government comes up and say, okay, we will give you everyone $1 each. Okay, now everyone got $2. So the $2 stuff would be more expensive. It will be now $4. The seller will say, why would I sell it at $2? I will sell it at $4 now because everyone got a dollar and I also got a dollar. So I don't want to sell at $2 now because I already got for a dollar extra. So I will make the price higher. So this is called inflation. Inflation increases when supply increases. So as money supply goes up, inflation also goes. But with Bitcoin, this currency, you have a constant supply. So supply is constant. You cannot increase the supply. And then the inflation is not there. Inflation is just zero. Inflation is zero. So this is one property of this currency, this Bitcoin, that there is no inflation actually. The only value it creates, the value goes up or down, is just by its trade. So if you want more Bitcoin, if a lot of people wants Bitcoin, there's an application and people wants to just use Bitcoin for that, the value will go up. If no one wants to go use the Bitcoin, the value will go down. So there is no inflation. So this is, it's showing 20,000 all-time low, $65. Okay, even it was lower than this. This is like, the chart is just showing until 2013, but it was actually $001 in the beginning. So it has no value in the starting. All right, so this is the basics of Bitcoin, but let's understand what is the technology behind it. So to understand the blockchain, the technology behind Bitcoin, the blockchain, we should understand what are blocks and and we will come back and forth between blockchain and Bitcoin to understand the concept. So just to understand the concept, we can maybe, so blockchain is essentially a database. So blockchain is a database. You guys have studied database in this course, so you understood how databases are. So databases are essentially tables. So these are the tables, and there are different information in the table. So there are rows and columns, and there are records in the tables. All right, so now there are different parties. So there is one person who is like has access to the table. This person also has the access to the table. So usually a database is like, if you need information, you go to this table, you change it, and you update it, and that's it. And then this person has his own database, his own table probably, or we can say that this is a ledger of records. So if any transaction happens, you record in this table. Now what happens in a blockchain kind of a database is that everyone in the party has a copy of this, and everyone can make a change. So all the parties, everyone can make a change to the table. Usually in a database, this is not possible. One person has a table and they make the changes, and others maybe view or see the database or tell this person to make the change. But this kind of a blockchain table is everyone has access to a table, which essentially means that everyone has their own copy. So this person has a copy of database, same. This person has the same copy. This person has the same copy of the table, and this person has the same copy of the table. And then if one person wants to make a change, okay, so this person wants to make a change in the table, and he's like, okay, I will add something in the table or delete something. It changes. If it has to change this table, he has to take permission from everyone. So he has to take permission from this guy, from each guy. This guy will take a permission and say, okay, can I make this change? Is this change valid? Is this a good change? Can I do this change? And everyone decides, okay, this change is okay or not. Every party has to decide if the change this guy trying to make would be okay change or not. So this is called consensus. So um, consensus mechanism is the backbone of blockchain, and everyone in the who has the copy of the table can see the changes, and everyone has to agree on the changes. So once this guy makes a change in the table, all the tables get updated because everyone is in agreement with the change, and all of them are making their blockchains updated. So any update in one block. So if there's a block, like there's a block here, and I'm trying to update this, a block will be updated here. And this guy has to make that update. And this guy will also update this block. And then this guy will also update the block. Okay, so each person has to update the block. And once the consensus is built, the update will be confirmed. If there is no consensus, if this person tries to cheat, others will catch him because their tables will show, okay, no, this change with this change you made here, you never actually talked to us. This is never agreed upon. This is a wrong change. You cannot do this. So this change will be deleted because others have the same copy. So the mechanism works with distributed ledger. So the concept here is distributed ledger. Distributed ledger. So this is the concept of a blockchain. So blockchain is essentially a database, but the database which is distributed, so no one person owns it or holds it. Everyone actually owns the blockchain, and everyone holds their own ledger, the copy. So this is the concept behind the blockchain. Now, what happened with Bitcoin? Bitcoin. So I made this spelling wrong. Bitcoin. So this guy Satoshi made a computer software and said we have to. During his research work, he came up with an idea by mixing different crypto techniques. So crypto crypto techniques are very old in computer science. They are used for hiding data. So cryptography is pretty old concept in the field of information security and computer science. So he said he has invented a method through which people can make transactions with each other by making an effort. And the effort is like mining. So he put a concept that if you want to make a transaction between two parties, so there is one party here, another party's here, and they want to make a transaction or send a message back and forth, they have to make effort to clear the message. Or there will be a miner. So a miner will be the person who will say, okay, I will help you guys clear this transaction, or I will send this message to each other and make sure that everyone's ledger is updated. No one has a fault. I will do the job. I will clear everything. I will see what you guys want to transact, what's the message, and I will transfer this. I will do the job, but I will take a small share. All right, so I will take a small share, and that would be in terms of Bitcoin. All right, so what this miner is doing, he's sending a message from this guy to this guy, which is essentially actually a Bitcoin. This guy does not have any Bitcoin in the beginning. So the first block, what happened when this guy made the whole computer software and he wrote the code, Satoshi guy wrote the code, and he made a software, and he said, okay, we can use crypto techniques and some other methods to make a consensus algorithm which will be very useful in clearing transactions. All right, so this was his point of view at that time. All right, so he wrote that in a research paper, and that's called Santoshi Bitcoin white paper. So you can actually Google this white paper, and he has all the things in it in an email with someone else. Actually, he sent emails out to another person, and he says, okay, all right, so I have developed a method in which we can do businesses with each other without knowing each other, while trusting each other based on the mechanism of the system. So two parties can transact between each other without knowing them, without knowing their identity, but they can still transact because there is a third party and there's a whole system verifying the transactions between the two. And he said this system will be based on blockchain, and each block of information will be linked to a next block. And miners have to mine this. Miners have to mine the block to find the answer for the transaction. So let me be more specific. So it's very confusing, I think. I should explain you what actually he did. For example, um, we should start at an consensus mechanism or a cryptographic algorithm called SHA-256. So this is another concept in Bitcoin. SHA-256 is the basis of Bitcoin. So Bitcoin actually works on SHA-256 algorithm. So what happens with SHA-256? It's a cryptographic algorithm. If you search SHA-256 hash, so it's a hash. All right, so hash. So the SHA-256 is a very old concept. It's not something new. It's been out there for a long time, but Satoshi just used this concept. And how he did what he did, he said we can use SHA-256 because it can be used for mining. in cryptography. So the property of this function is actually a function. So it's a hash function. Whatever you give inside this hash function, whatever you feed to this function, it will produce a random numbers, which are like, you cannot guess what's the input. So if I type here Ali, it will produce these numbers. All right, so it will produce a long digits of numbers. So from this number, I can never understand what was the actual message. So it's cryptography. So whatever I will type here, if I will type here, I will get this number. If I send someone this message, they can actually never get to this message. They can never know, they don't know what is the underlying message because it's totally encrypted. It's totally hidden. But the good part. So yeah, so hash 256 function is a function in which is a cryptographic hash function in which whatever input you will give, you will get a large number of random code generated by the function. You can never understand what was the input of these numbers. Even if you know this is a code generated from hash 256, you cannot decode back to 250 to the actual text. So it's cryptographic, it's hidden. It's very hard unless if I tell you some more information, then you can actually predict from the background of it what it can be. So what happens, so this has been out there for many years. This has been out there since 1980s, hash 256 function. So the concept behind is that, or the one of the application of this function is this. For example, if there is a software code, or if there is a huge software code. For example, if someone develops a software and that person puts it online and say, okay, this is a software for video editing, for example, and this is the code. If you download, you have to just compile it. Like you have to build it, compile it, run it in a compiler, and your software will be there. So it's free for all, and there are no bugs, there are no problems in it, there is no issue, but it's free and it's online. But some hacker takes that code, add few lines in it, and they just want to maybe attack your system. The overall code looks same, but inside the hacker has added one or two more lines, like if they have added one space. So what the software developer will do, he will say, okay, this is my whole code. So the whole code he will put, and he will put in a SHA function. He will put the whole code and he will generate a SHA code like this. And the software developer will say, okay, this is my code, and this is the SHA or SHA hash, SHA-250 hash of my software code. And once you download my code, do check if this code produces the same SHA or not. If it produces the same SHA, you're good to go. You can use my software because this is the genuine I have created. This is the original piece. No one has changed anything in it because it's open source. Anyone can open and change few lines, enter their bugs in it, or they can enter something to track your behavior, or they can track you or your activity. But if you enter it in a SHA function, the whole code, like you will copy and paste in a SHA function, you will get this hash out. So if it matches to the hash, then it means the code is genuine. So the code has not been changed. But if someone has tweaked the code, if they have just added one space in the code or a dot, the whole SHA would be different. So you will not get the same SHA output, hash output. So the hash would be different. So then you will know, oh, I'm not going to use this software code because somebody has tweaked the code. I need the original code. This is not the right one. So somebody on the internet, they're saying is the same software code, but it has been tweaked. So you can verify the authenticity of a document. For example, if I have this, if I have written this whole document, and then I say, okay, this is my whole document, and I say, okay, and I have put in here, it creates the SHA for this code. But if somebody, or if somebody say this is their document, or they say, no, this has been produced before, I will say, no, how come? Because this is the SHA I have made. And if they have made any changes to my document, I can see the SHA got changed. So I will run the whole document. I cannot visually see any changes. I cannot read line by line. I cannot go, if it's a huge document, it's like thousands of pages, I cannot really see it. But if I put it in a SHA, SHA will tell me right away, is this the same document or not? So that's how you can actually use SHA, and people use SHA function a lot. So a lot of open source code, they actually give a SHA code with the open source program. They say you can run and check if the program is genuine or not. So this is the application, but Satoshi used this application, and he used a few techniques from economics and game theory to build his Bitcoin. So what he did, he said, okay, if there are two people who want to do a transaction of a Bitcoin, and he said he said if everyone has to make blocks, have to resolve the blocks. So the Bitcoin works in blocks. And he said the Genesis block he made by himself. So Genesis block was the first block, and that block was like not mined. It was just produced by him. In that block, he say, okay, transaction number one, he gave transaction ID. So a block usually has just text. A Bitcoin in the block, it has text. So he said transaction ID, okay, owner ID or owner name. And he said, okay, block number one, and Bitcoin mined through this block is 50. All right, so 50 mined goes to the owner. 50 Bitcoin. So the first one is like, this is the Genesis block. He made it, and all the other block after that is mined. So the first one is not mined. It's the only, and the rest, even he mined if he has to get more Bitcoins. So the first 50 Bitcoin, he got it from the first block. And then there's another person, he said, hey, why don't you send me some Bitcoins, or like 5 Bitcoins. And the other person, and Satoshi say, okay, we can do that, but whoever will mine the block will get the reward. So he said, we can do the transaction, but there is a reward for clearing a transaction between two parties. So two parties, so this is party number one, he has 50 Bitcoins here. There's a party number two, and he has 0 Bitcoins here. He said to Satoshi, okay, I will give you $1, just give me 5 Bitcoins. All right, or I will give you a pizza, give me 5 Bitcoins electronically. And Satoshi said, all right, we can do this transaction, no problem, but we need someone else, or we have to work together to mine the transaction, to clear the transaction. And he said, by clearing, we have to put some effort. Everyone cannot say, okay, the transaction is clear, everyone is fine, you take my 5 Bitcoin and I will be happy. He said, all right, so we have to put some effort, and effort would be done by computer. He said, how the effort can be done? He said, I will give you my transaction ID, my block, and then we want to clear this block, so a new block. So there will be like transaction ID here, transaction ID, and there will be owner, sender, receiver, receiver name, owner name, and block number 2. And how many Bitcoin? 5 they're sending. All right, so this is a transaction block. You have to clear it, and we have to put some effort to clear this block. And then they were like, okay, how can we put the effort? We have to show that we have put some effort. So for example, there are another miner also. He's saying, okay, I will put the effort. This guy is saying, I will put the effort, or the Satoshi is saying, I will put the effort, but we have to make the transaction clear. And the reward for the effort is 50 more Bitcoin. So whoever will put the effort will get the 50 Bitcoins as a reward. Now, what is the effort? Why can't we just send it to them? Well, this is the game he put it in. So this is the game theory, or the game behind it. You have to put some effort. So you have to give a proof of work. So the concept here is called proof. You have to show proof of work. And once you show the proof of code, you can clear a transaction. So he said, let's take all this text and run it through a SHA. So what happened here? What happened is, say, we have to find a SHA. So transaction ID was, for example, 2. Sender was like Satoshi. Um, receiver was another person. Receiver was another person. And there was amount, for example, amount was 5 Bitcoins. And time date time was something like back in 2019. For it was like not back in 2009, it was like January 1st 2010 at some time 10 a.m. or something. Okay, so he said this is our transaction text. Okay, so this is our block text. Now he said to this guy and this guy and to himself, okay, whoever find a hash function with having 8 zeros in the beginning, they will be the miner, they will be the winner. All right, so he said this is the transaction text, but I don't need the hash function. All of us will find a hash function by having zeros in the beginning. Now he said, how can we create a hash function with zeros in the beginning? He said we can add some random text in the beginning. For example, first time we will try A. If A doesn't work, we will put B. Then we will put C. Then we'll put D. Then we'll put E, F, G. So they will keep putting the stuff until they will keep putting, and by then they'll put A, then they will put AB, then they will put AC, then AE, and then if they don't find the hash, they will keep putting until at some stage, for example, this one. So for example, ASSSS, they found 1 0. All right, so the computer, so what they don't have to do this manually. So computer software will search for these zeros. They will say we need 8 zeros before the hash function, and once you find that, you will say this is the original text and this is the additional hash. If you add, you will get the 8 zeros. So this is like 1 0. Computer will search quickly. The miner is actually a computer. They will search for another 0. They will say, okay, this is S, like try to find an 2 0. They will try to do anything to get 2 0. All right, so in this way, so it's 1 0 is coming like 2 0. Okay, it was 2 0, something like that. So the miner will search for it like all possibilities, every possibility of alphanumeric letters to add in the end of the original block to find the hash, which has 8 zeros. So once they find it, so once there are 8 zeros and some random text, the miner will tell the network. So it will tell to this guy and everyone else. He say, I have found a hash for the block. And others will say, okay, what is the hash? He said, I have done my proof. I have done my work. I have a proof. He say, okay, if you add just like some text, like you say, okay, this text, for example, if we have got 8 zeros by this, if you add ASSSSS, you will actually get 8 zeros and then the hash for this block. And within seconds, this guy, or anyone can check it in their own hash computer. They can also check it and verify it. Once they say, okay, this guy has proof that he has done the work, or his computer has done the work, his computer was the fastest to create all possibilities of zeros in the beginning and then found a hash, he say, okay, he has resolved a hash for this block. And they will attach the hash. So what would happen here, they will say, this block has been resolved, and the hash for this block, they will actually put the extra thing, the extra code they have found in the end and say, this is the hash for the block. And this guy has found it. And now the $50 goes to this guy, a $5 will goes to this guy, or whoever is the miner. If this is, for example, this is the miner, he will get the $50 reward, and this guy will get the $5 of the transaction. So this guy's balance is 45 now. And this block has all the information. So it knows Satoshi, or the first guy, has 45 now. This guy has 5 now, and a third person has 50 now. So this block has all the information. It just appends to it. And then this block is created. And then another transaction is made, and a third block has to be cleared again. Now, this hash and this whole text will come in the header. So the header of the block has the whole text. And then the information comes in, transaction ID, everything will comes in. So the header is there. Even the header was here too. Header was here too. And then transaction ID and everything comes in. So in this way, another block is there. And as this blocks comes up, all the miners will start working hard. Like their computer will start working like crazy. They will try to find the hash. And a miner or a computer, when it's trying to find an answer for a hash function, it really takes a lot of power. It takes a lot of energy. It takes like tremendous amount of CPU power to find the answer. Like defining 8 zeros in the beginning is not an easy task for a computer. They have to put a lot of power, a lot of resources, and put all possible combinations. Sometimes there are millions of combinations to put 8 zeros in the beginning, sorry. And once they have it, and that's why they are called miners. So they have specialized kind of computers. Their job is to just clear the transactions. For example, if I go right now, I can actually see Bitcoin hash. So it's saying me like Bitcoin hash uses hash 256 hash algorithm to generate verifiable random numbers in a way that requires a predictable amount of CPU effort. Great. So there's a power, there's a check type and everything. Okay, so if we go here, so this is like hash, how many hashes are done per second. So millions of hashes are produced. So the Bitcoin, each one is So these are different miners. So these are the miners. They're like sometimes they work in a group, and I just want to show you few hash block details. Yeah, maybe block details. Network activity maybe has it. No, I'm actually trying to find a blockchain Bitcoin hash. Bitcoin hash transaction block. Yeah, Bitcoin block explorer. So if you see, this is like just 5 minutes ago, a miner called Paulin found this hash function for a block. And do you see these zeros? So these zeros are increasing. It was actually less in the beginning, but with each difficulty, like more miners comes in, the number of zeros they have to find also increases. So this was the hash this guy found for this block, and this is the timestamp. So transaction number and everything is here, bits, size, everything. So he got reward of 12.5 BTC. So yeah, so in the beginning, the reward for mining a block is 50. Then once the 4,000 block has been mined, they half it. They half it to 25. Right now, the reward is 12.5. So after every 4,000 blocks, they half it to half. So right now it's 12.5. Actually, Bitcoin halving is going to happen next month, which is another a huge event in terms of Bitcoin thing. So there is a lot of hype going on. Bitcoin halving price rally continues to 8,000. So whenever the halving happens, the Bitcoin goes like really up. This is like because you are cutting the inflation again, you are dropping down the inflation. So Bitcoin inflation, so for example, the Bitcoin inflation was here. It just dropped with the first 210 block. It dropped here again 4020, it blocked again 2000 blocks, it dropped again inflation. So here right now we are actually in here. So we are really killing the inflation. So inflation is going to be really zero, really less after this halving. So the Bitcoin halving is going to happen. I think the countdown is like in 13 days, the reward will become 6.5. Right now, the reward for each coin is 12.5, but on after 13 days, once the block 6030 block is reached, the reward will be 6.25 coin per block. So in this way, the inflation will go down dramatically, and inflation over time is actually increasing. So all the things happening right now, everything is technically getting expensive. We don't really feel it, but over time, inflation is getting expensive. For example, in this pandemic, there's a lot of money has been rolled out by governments, stimulus checks and everything. So it's like giving everyone money is actually increasing inflation. People don't realize that, like, if you give everyone money, inflation would be higher. Everything what you're going to buy for the same amount, you cannot buy it. You need to put more money to buy the same thing. And it sometimes it takes some time to take an effect. It wouldn't happen overnight, but it will happen. Like inflation will technically increase over time. So this is what they're showing, like inflation is going up. However, Bitcoin inflation is dramatically going down with each halving. And by next few years, like 2025, it will be very low. 2029, it will be like 0.000001 maybe. And so on and so forth. So here they are talking about like there are 21 um, every 21,000 blocks, approximately 4 years. Yes, sorry. So I mixed up this number. So every 4 year, approximately 4 years, the Bitcoin halving happens, and the every 21,000, 210,000 blocks, there's a halving, and block reward will keep going on until it will reach to zero. And to reach that, the last halving, when it will happen? It will happen in the year 2140. So right now we're talking about this, and this phenomena is for next more than 100 years. So think about it. Bitcoin is built in with the planning, with the scope in mind, like with the computer, with the power. They are estimating that the last Bitcoin, because there are 21 million total Bitcoins to be ever produced. So they're mining slowly, and they have mined almost 18 million, but the the last Bitcoin will be mined in the year 2140 approximately. So if some computer technology comes in, like a really supercomputer, like a quantum computer, and they want to mine it, probably they can mine it, but they can mine it pretty quickly. But that's not the case right now. People are not thinking that that would be a case, like some supercomputer or like some quantum computer can quickly mine all of them, quickly resolve all the difficulty of the Bitcoin and take out the last Bitcoin. That can be possible, but right now, based on the speed and everything, the difficulty will increase so much as the more technology will comes up. The difficulty of solving a block will be much higher. So by the year 2140, probably we will mine the last coin from the vault, and then there will be no Bitcoin left in the vault. The only reward, the miners, there will be still miners even after that, and their reward will be coming from the percentage of the transaction. So if you mine certain, if you want to send some Bitcoin to someone else, you have to give some percentage of your transaction. That's how it will be. According to some estimates, some people say the price of Bitcoin will be maybe $1 million. So by some time, a Bitcoin will be $1 million. So some estimates, some economists actually have this kind of estimate. I don't know it will be there or not. Maybe it will die down. It will become zero, and no one likes this technology, and it dies out. And there is never ever there is going to be a mass scale adoption. But there's a possibility that it can reaches a really high value in future. All right, so this is the last lecture. I want to thank you, all of you, for listening to this lecture. So it was a great semester with all of you. I hope you guys have enjoyed this semester. You guys have enjoyed this course. We would have done, I think, much more if we were in class. We could have achieved much higher things, but still, I feel we have done what was the core syllabus, core requirement for the course was. We have covered all of that. So I want to thank all of you, and I appreciate for listening to this video. Thank you.